Okay, so we are going to be looking at inverses of logs and exponentials. So you actually did a little bit of this in the book, but I felt like it wasn't covered enough. So we're going to spend some time practicing this a bit more and also with more complicated problems. So I will say that these get to be a bit tricky, and the best way to learn them is to practice them. So we're doing quite a few examples. If it would help you, you could write them down. Sometimes people learn by writing, but if it helps you to just watch, you can do that as well. The homework tonight will be essentially just more problems like these. I tried to make an example in here that matches each of the homework problems, so you shouldn't have any issues. Okay, so we're going to first look at find the inverse of an exponential. So we know automatically that the inverse of an exponential should be a log. So kind of like what I said in a previous video when we're finding inverses is you want to just change it into that other form first. But before you do that, you have to make sure it's in that like sort of parent function form. So in other words, I don't have any surrounding numbers. So for example, if it was like 3 to the x and it had a plus 5 on the outside, I would have to subtract that first. But luckily, it's in that nice form. So the first thing I'm going to do is just rewrite it as a log. So this would become log base 3 of y equals x. So remember, in order to find the inverse of an exponential, you solve for x. So the reason we kind of wrote it in log is because that will solve it for x. But then after you do that, you then have to switch x and y. So then our inverse would actually be y equals log base 3 of x. So this right here would be your answer. Okay, so the next one is pretty much exactly the same. We just have a different base. So this time our base is 7. So I'm going to rewrite it as log base 7 of y equals x. And then I just want to switch x and y because we always want it in terms of y. So y equals log base 7 of x. And that would be those problems. Okay, so looking at the next one, it's not in that nice form, right? Because the exponent is 1 over x. So we have to figure out how can I get it in that nice form? Or in other words, what could I do to get rid of that 1 over x? Because we can't have it in that form if we're trying to convert it to log, it needs to just be x. So what we could actually do is raise both sides to the power of x, because thinking about that, if we do that, 1 over x times x is just 1. So then we end up getting something like y to the x equals 4. Okay, so now it kind of switched things up on us, but we could then, because it's in that nice exponential form, we know that we're going to have to convert it to a log, so we will go ahead and do that. So this would be log base y of 4 equals x. So now I solved for x, so then I would just switch x and y. So y equals log base x of 4. So obviously it looks very different because this time our x is actually our base instead of that larger number. So again, when we have something like that, you raise both sides to the power of x, and then you end up getting a variable raised to a variable, but you could still write it in terms of log. Okay, this next one. So you can see these are getting pretty tricky, but that's why I said practice, practice, practice. So this one is 6 to the x over 3. So again, it's not just 6 to the x, so I can't just go and do how we did our first two. So what we can do is kind of similar to the last one, but this time we're going to raise it to the third power. Because when we do that, that 3 cancels out, and then it becomes 6 to the x, which is what we want. So this would become y cubed equals 6 to the x power. So now we can then write it in that in the log form. So this would be log base 6, but instead of just of y, it's going to be of y cubed equals x. So then you can see that we already solved for x. So we just want to switch x and y. So this would be log base 6 of x cubed equals y. And we don't really need the parentheses around the x cubed. You can have them there, but you don't have to have it there. Okay, next we have y equals 2 to the x plus 5. So this is kind of like what I was saying in the beginning. So again, we want to just have that parent function form. So since we don't, I'm going to go ahead and subtract 5. So this would be y minus 5 equals 2 to the x. So now I have that. So then I'm going to write it in log form. So log base 2 of y minus 5. In this case, I would want to put it in parentheses to make sure that we're taking log base 2 of the y minus 5. So you can see we already have it solved for x, and then we'll just switch to y equals log base 2 of x minus 5. And I am going to highlight those. Okay, so next we have y equals 3 to the x over 8. So this one's pretty weird. It looks weird, but it's actually not that difficult because it's almost in that nice form, but we're dividing by 8, so we will just multiply by 8. So we would get 8y equals 3 to the x. So then we can write it in log form. Log base 3 of 8y equals x. So we just solved it for x, so then we can switch. So it'll be log base 3 of 8x equals y. And that would be our final answer. Okay, so here we have our last one, which is the most difficult, of course. So this one we have a bit going on. We have a 2 times 9 to the x in the denominator, so it's different than the last one. So the first thing I want to do is let's try and get that 9 to the x by itself, right? That's been our goal for each of these, is to get that base to the exponent by itself. So that would mean we'd have to multiply by 2. So then I would have 2 to the y equals 1 over 9 to the x. Okay. Now this is where we get a little bit stuck. However, okay, let's think about this. If we have 1 over 2 cubed, that would be 1 over 8, right? So because of the 1, if I make this 1 over 2, the whole thing cubed, it's still 1 over 8. So you're probably like, okay, what does that matter? Well, because instead of writing 1 over 9 to the x, I could actually change this to 1/9 to the x power, because 1 raised to any power is always going to be 1. So this would actually be 2y equals 1/9 to the x power. So because of that, now we can go to our log form, right? So this would be log base 1/9 of 2y equals x, and then we can rewrite it. Y equals log base 1/9 of 2x. So strange, but it works. Okay, so now we are going to do the opposite. So we are starting with logs, and we want to go to an exponential, obviously, because we're finding the inverse. So for these, kind of the same idea, right? You want to isolate, so it's in that nice parent function form, and then you want to obviously rewrite it as an exponential. So first of all, there's no base here, but we should all know that this is actually, I didn't mean to write in highlighter, this is actually base 10, right? If we don't have a base, then we assume that it's base 10. So it's already kind of simplified, so we can actually just rewrite it in the exponential form. So it'd be 10 to the y equals negative 4x. Remember, my goal is to solve for x. So all I would have to do is divide by negative 4 on both sides. So then I would get x equals 10 to the y over negative 4. You're probably thinking, oh, can't I make that, 5 over negative 2? No, because 10 is raised to an exponent. So if it was just 10 over negative 4, we had no exponent, then yes, absolutely. So then remember, the last step is to change it to y. So y equals 10 to the x divided by negative 4. So that would be our answer. Okay, next one. So we have y equals log base 1/2 of x cubed. So I'm just going to rewrite this in exponential form. So 1/2 raised to the y equals x cubed. Okay, so in this case, I'm trying to get x by itself, and we have it cubed. So we'd actually cube root both sides. So we are going to cube root both sides. So this one does get a little bit messy. So first of all, when I have 1/2 to the y, keep in mind that that's actually 1 to the y over 2 to the y. Okay, so I'm going to kind of rewrite this. So 1 to the y over 2 to the y, and that's all the cube root. And now this is just equal to x. So let's go ahead and simplify that even further. So 1 to any power is just going to be 1. So I don't really need that 1 to the y. Now, if I have the cube root of something, if I want to rewrite that as a fractional exponent, for example, it would be 1 to the 1/3 power and 2 to the y-thirds power. So I'm going to rewrite that. So this would be 1 to the 1/3 power over 2 to the y-thirds power, which means you take the cube root of 2 and then raise it to the y power. Now, thinking about this, 1 to the 1/3 is just 1, right? And this is kind of going back to this one right here, how we talked about, well, if it's just 1, we could actually move that exponent to all of it, right? Because 1 to anything is going to stay 1. So to make this even more simplified, I'm going to say that this is actually 1 over 2 to the y over 3 power is equal to x, and then we can just change it into y equals 1/2 to the power of x over 3. Now, that one was super difficult, so I would definitely, if you need to rewatch that one again, it just gets a little bit tricky with all those exponents and radicals. Okay, next one, we just have a few more, 3 more. So on this one, we can't automatically write it in that exponent form because we have that -2. So our first step would be to add 2. So we'd have y plus 2 equals log base 1/3 of x. So now we can write it in exponential form. So it would then be 1/3 raised to the y plus 2 power equals x. So x is actually already solved for, so then we can just change it to y. So y equals, and I'll make this a little bit bigger, 1/3 raised to the x plus 2 power. So that one was a little bit easier. Okay. The next one. So this one, because that 6 to the x minus 6 is all in parentheses, we can immediately change it to exponential form. It's just going to be a little bit messy. So we would have 5 to the y equals 6 to the x minus 6. Now the problem is, remember, we're trying to solve for x. So the next thing that we would do is add 6. So this would be 5 to the y plus 6 equals 6 to the x. So I'm still trying to solve for x. So this one's a little bit twisted because the only way to solve for x would actually be to write this in log form. So then I would do log base 6 of our answer, which is 5 to the y plus 6, and this is all equal to x. So this one's kind of, it goes from a log to an exponential back to a log, but I did solve for x. So the last step would just be to write this in terms of y. So y equals log base 6, and this would turn into 5 to the x plus 6. Okay, and our last one. So we have y equals -4 log base 3 of -5x. Now that -5x is okay, but I need to get rid of that -4. So the first thing I'm going to do is divide by -4. Now when I divide by -4, I can leave it like that, but anything when we have a fraction, like I can have it as 1 over -2, -1 over 2, or just -1/2. All of those mean the same thing. To make things a little simpler, I'm going to just leave it on the outside, and you'll kind of see why later. So then we would have negative y over 4 is equal to log base 3 of negative 5x. So now that we have it in that nice log form, I can then change it into exponential. So it would be 3 to the negative y over 4 equals negative 5x. So our next step is to obviously get x by itself. So we would just divide by negative 5. So we would have 3 to the negative y over 4 divided by negative 5, and this equals to x. So some of us are probably thinking, great, we're done, right? Well, the problem is we can't have negative exponents. So in order to get rid of that negative exponent, think back to just like a basic one. If I have 2 over negative 3, this would actually be 1 over 2 to the positive 3. So what I need to do is actually move this to the denominator. So this would become 1 over 3 to the positive y over 4, and this is all times negative 5, and that's equal to x. So my final answer would be y equals 1 over 3 to the x over 4 times negative 5. So I would suggest, if you are still confused, to obviously re-watch this. And then we have lots of practice problems on the homework tonight. So just take your time working through those.